Right? So we've gotten out of liters of O2. Now we're in moles of CO2 through our, this is our Stoich step. And now I can get out of 1 mole of any gas. How do I know that carbon dioxide is a gas? It's labeled, equals 22.4 liters of carbon dioxide. All right, you ready for some magic?
No, I love magic. I hate magic.
Look, 22.4 on top, 22.4 on bottom.
Take it away.
5 on top, 5 on bottom.
Wow, that's racist. What?
What are we left with? If you don't believe the magic, put it into your calculator. Shh.
When we aren't using statements on like a decimal answer, we put like the places plus the decimal. So if it's just a solid number, do we have to put like point?
No. So this happens to be one of the very few times this year that your calculated answer should also be your sig fig answer.
It happens a lot on the homework.
Okay, so that's okay. That should be a celebration, right? Okay, so that's a review of stoichiometry. Once again, how do we know that we can go straight into stoichiometry? Because we're at STP. All right. That is all review, guys. We've done that before. Now comes. This is the fun part. I know you're all waiting on it. All right. So this is our notes, and we're gonna write these notes at the bottom. And once again, you should review these and reference them as you do your homework. So this side is all at not STP. That's the big kicker. So because it's not at STP, we have to use the ideal gas law at some time. Okay? Because our temperature and pressure are going to change. So how do we know how to get these ones started? Here's what you need to write down. So when we are not at STP, if your given is your liters, or technically volume, because you might be given milliliters, and that's the same thing, then you should start with your ideal gas law.
Is that Pivnik?
That is Pivner. Okay? Then you go to stoichiometry. Okay? But you start with your ideal gas law, then you plug in the moles that you're going to find into your stoichiometry. If you're solving for your liters, which is your volume, then you start with Stoich. Then go into your ideal gas law. So you're not getting out of one or the other. It's just which one are you going to start with to solve for whatever it is you need to solve for. Okay? So your kicker here is what's going on with your volume. Okay? Is liters given, or are you solving for it? Okay, so let's look at some examples here. What mass of hydrochloric acid? That's what that's what I need to get into eventually, right? So if I want to come down here and already get my answer box set up, I need to get into grams of HCl. Must be reacted with calcium carbonate, so that's what I have right here, to make 50 milliliters of carbon dioxide at not STP. Yes? Not STP. So, what's given to me? Temperature, pressure, volume is given to me. So what do I start with?
No.
Volume is given to me, so I start with ideal gas law. Now, just some test taking strategies. Go ahead. Remember that this is 3 sig figs, but go ahead and turn that right into liters. Oh, sorry. Thank you. There's 3 sig figs there, but go ahead and turn that right into 1, 2, 3. Should be what? And if you want to put, well, I guess 0.50 to make sure you keep those 3 sig figs. That's the liters, right? And if I want to rewrite PV equals nRT just so I can reference it as I'm working, your pressure is in a good pressure of 1.15. Your volume is 0.0500. You know you're going to be solving for N because your constant is there, and your temperature is 290 what? 297. And now you're going to solve for N. Once again, put it all into your calculator at one time. .5 times 0.0500 divided by parentheses times 297. Raise your hand if you agree. Our calculators agree. Good. So here's where sig figs are going to count. But if you have a calculated answer that's close to mine, you'll still be okay. But if you want that sig fig point, you got to know from this calculation how many sig figs should we report right now? 3. Because that's that 3 there, 3 there. We haven't used these yet. Well, yeah, we did. On this one we did. 3 there, 3 there. So N equals 0.002 moles of what? I guess it's going to be
That's not 3 sig figs.
0.00236. Because these zeros don't count.
Yep.
They're placeholders.
Yes, these sig figs not. Yeah. I put the zeros after the decimal.
They have to be trailing after the decimal.
Yeah. And I said it has to be at the very end.
So this is our amount of moles of carbon dioxide. So what do we do after we find N? We do stoichiometry.
Yep.
So I have moles of carbon dioxide, and I know that moles of carbon dioxide can be turned into, well, I want to get into hydrochloric acid, right? What's that?
How do you know it's not?
Because this label right here, right? This amount of this gas can only equal the same amount of moles of that gas. So moles of this gas and then moles of hydrochloric acid are in a relationship of
2 to
1 to 2. So now I'm out of moles of carbon dioxide, I'm in moles of hydrochloric acid, but I need to be in grams of hydrochloric acid.
Molar mass.
So I know that 1 mole of HCl is equal to the molar mass of HCl, which is 36.46 what? Now I'm out of moles. I'm there. So I take 0.00236 times 2 times 36.461. And that's it. We don't divide by anything.
Oh yeah, it's all one.
How many sig figs? Look back up. 3. So I should, my calculated answer will be 1721, right? My sig fig answer, 172 grams HCl. Any questions there? All right.
You got 17, 21. Oh, never mind.
Number 2. This is the best question you've seen all year.
Is that like for real? Or
Yeah.
oh,
Always kidding.
he was being sarcastic.
No sarcasm here.
See?
What do you mean the best?
Most torturous.
Exactly.
Here we go. So let's figure out how we're going to start. Ammonia reacts with oxygen to make nitrogen and water. What volume of nitrogen? So I'm going to be looking for liters of N2 as my answer. Is that? This is going to be a long question, so make sure we kind of know what the end game is. I need liters of N2. Would be produced from reacting this amount of ammonia and this amount of oxygen at this pressure and temperature. Are we at STP?
No.
Definitely not at STP. So, am I given liters or am I solving for liters?
Solving.
I'm solving for liters, which means I need to start with stoichiometry. Well,
You need an equation.
what do we need to do here to figure out what to plug in for our...
Right, balance
We need to first have a balanced equation because we will be doing stoichiometry, right?
Yes.
We're going from one thing into the other. So that's step 1. I start with ammonia. I add it to oxygen, which is what? Diatomic. That produces N2 and water. So you all should be attempting to balance that right now. Raise your hand when you have this balanced.
Got it.
Watch out!
Two people have it. 3, 4, 5, 6. Do you have all even numbers?
No.
Good.
What's wrong with even?
That can be reduced.
Oh, that makes sense.
Jacqueline. Ratio. What? What? Say that one more time. Raise your hand if you got those coefficient numbers. Come on, Jacqueline. So now we have our balanced equation. We start with stoichiometry to figure out what we're going to plug in for N.
That's what we're solving for.
So we're solving for moles, right? But we've got a problem.
We have kilograms.
It's not in the right units.
It's in,
Kilograms.
so we do need to have it in grams. But then, what's our biggest problem? What kind of problem are we going to be doing right now?
Hibner.
We don't know how many moles we have yet.
Dimensional.
We have to start with.
Dimensional analysis. Oh yeah. We have to convert the kilograms into grams.
Which one?
Ammonia into nitrogen.
Either one?
Hopefully. We gotta do both. There's no way.
No, we
Oh
cannot.
my
No, we're not doing. No.
Well, we're not using both numbers.
It's small numbers.
No.
You have to have to, right?
You have to use both to get the.
You have to know.
The
Why are you
just,
smiling?
It's
the
asking
least
for,
amount.
it's asking for a
What type of problem is this?
Everything that we freaking went over.
Oh, wait.
Don't say that.
Everything.
Starts with an L.
That's me.
2 words.
Eater.
Long.
Second word starts with an R.
Long retarded.
Less than. Wait, what?
My bad. That's-
No, that's not funny.
It's like less. It's like.
That's right. No.
Oh, something reaction. Right?
The lesser reaction? Like the.
It's when you.
The
The loser. I don't remember it.
It's when you use both of them, and the one with the least is the one that you.
Oh my
use.
gosh, we're doing
Yeah, what is it called? I can't remember. Could you like just tell us?
Oh wait,
There you
don't
are.
tell me.
You took a test of
Different
it.
reaction.
It's coming.
Yeah, I did.
Limited reaction.
Thank you,
Limited.
Lindsay. Limiting reactant.
I almost got it.
Wow.
No!
So we are doing our limiting reactant. Told you it's going to be fun.
This is our
There.
special kind of sadist.
What?
They find enjoyment from our pain.
Hey, let's not use that word again in here.
They find
What's
enjoyment
sadist
from
mean,
our
man?
pain.
Hey, look.
No, here we go.
Jesus.
So because we have 2 reactants that we want to get into a certain product, which reactant are we using?
Oh no, we can use
The
ammonia because
smallest
it's.
one.
We don't know.
We gotta convert it.
Because limiting one.
We have to find the limiting one, which means we have to find the limiting reactant.
Oh, that's the hardest unit I've ever done.
Well, let's get started. Here we go.
Why is it hard to in with this?
So we can't use kilograms because molar mass is in grams.
Yeah, huh?
So we first have to convert into grams, which is
Isn't it times 1,000?
5,000 grams of NH3, which, be careful, remember that there's actually 3 sig figs that are a part of that,
So it's at just. Oh.
right? Now, if you want to add, you can't really, if you want to put scientific notation down, that would be the correct way to notate it, or you can just remember there's 3.
Okay,
And then down here, once again, 8,000, but we're technically using 3 sig figs, grams of oxygen. Go ahead and find your limiting reactant.
What am I making them go to? Moles?
Yeah, so we can stop. Remember, so I'm glad you said that, Quinn. Guys, listen. Hey, y'all are working, and that's great. But listen, we're looking to get to ideal gas, right? To plug in for one of these variables. Well, that variable is N, which stands for what? Moles. So are you converting each one of these into grams or into moles?
Moles.
So you can stop at moles. It's actually a pretty quick limiting reactant question if we didn't have to do anything else, but we do. So
What is above the numbers?
I think that's.
what do you mean?
What did you put above the numbers?
there's 6 big counts.
Yeah, those are to remind me of sig figs. There's actually 3.
We round to the sig figs for this part?
Yes, to this one, because those are the only measurements we've used so far.
Bro, sorry, I was doing math homework too.
We run the sig figs right now.
That's square root. Square root 1. Square root of imaginary 1.
Yeah.
That's what that was.
So
You see me trying to write it
Don't look up here if you're not. If you want to finish, I need to get out of grams of NH3 and into moles of NH3, right?
It's in scientific notation.
And we've already found the molar mass of NH3 once.
Oh.
Yeah? 17.031. So now I'm out of grams. I need to get into moles. I'm in the moles. Now I can get out of moles of NH3 and into moles of nitrogen.
Wait, what's the gas for H3? Like, sorry,
Wait,
the
why?
grams.
Wait, why are we doing both of
It's
them?
17, 0.17.
Yeah, it's the same as the front.
This is
Limiting
like,
reaction.
oh, we're taking it to moles of nitrogen.
Yeah, look. Moles of liters of nitrogen. We need to get into
Yeah.
moles of nitrogen.
Yeah, it's
We're
limited reaction.
trying to figure out which one's the limiting one, so we know which one to use.
So I have 4
It's basically combined.
to 2. Yes?
Yeah.
That should give me an answer. You want the lights off again? Brandon can get the lights for me.
Wait. Wait.
Waiting.
Oh, wait. It's just like I thought we were only supposed to be converting them into moles, right?
Yeah.
Right? Yeah. It's just that like I currently have them converted into moles of NH3 and moles of O2. Which is that why exactly are you trying to convert them into moles of N2?
Because we need when we use Pivnert,
Uh-huh.
we need our volume and our moles to be the same unit,
Uh-huh.
which is the same compound.
Yeah. It's I thought we're currently just trying to figure out which one's the limiting reactant. Why are we trying to do the entire equation on one that's probably the limiting, that's probably not the limiting reactant? It would be just a waste of time.
How do you know which one's the limiting reactant?
Oh, because I currently have them both converted.
That's what we're doing right now.
I have them converted into moles of NH3 and moles of O2.
It's not the same unit.
That's not the same unit. You need to have the same compound of N2.
Oh, I see. I have negative IQ. I'm dumber than a pile of dirt.
Don't say that.
Okay? So you should get an answer
So
here.
you're telling me to lie.
Then you should do it's the same process down here. So we have grams of O2, moles of O2, and this should be like 31.998. That's the molar mass of oxygen.
Yep.
We're turning it into moles of oxygen, and then out of moles of oxygen and into moles of N2, so they're both in the same units. So that's 2 to 3, or 3 to 2.
We just need them more.
What?
So we can
Yeah,
swap.
because N is in moles, right? We're trying to figure out what we need to plug into Pivnert.
Ammonia. Limiting.
Oxygen to nitrogen.
Oh, we're trying to.
NH3, if I guess I can do this so you're not confused. Ammonium, oxygen. So when I do this, I get 147 moles because of 3 sig figs. And down here I get about 166 moles because of sig figs. Yes?
Wait,
Yeah.
so if you're going that far.
Or 167?
So if you're going that far, why wouldn't you just finish it and change it to liters and then take the smallest liter?
Because we're not at STP. Remember that? Remember? If we were at STP, then we could. But we're not. So, which one am I using? The least amount,
So it's
147. So now, this is my new N that I can plug into Pivnert. My pressure is 3.25. My volume I'm solving for. My moles is what I just calculated for my limiting reactant.
Does the limiting reactant count as stoichiometry?
Yeah. And my constant and my temperature is not 550, but 823. And now you can solve from there. 147 times 0.0821 times 823 divided by 3.25. My calculated answer 30561662.
Yes.
Wait,
I'm
is
still
it
writing it down.
and that's liters.
I love when I get the right answer. Feel like I've done work.
How many sig figs?
It's
Three.
three, yeah. No, two.
Two, because your temperature, right?
Oh,
Which means it's going to be
31.
3,100 liters of N2.
Wait, what is the temperature?
Two.
That wasn't
Wait,
bad.
take-
For
What?
yourself.
Oh,
Speak for yourself.
oh, it's because of the 550?
For yourself.